Hello friends, welcome to another C++ or C interview question. And the question is how to print something. Let's suppose you want to print CPP nuts, but without using semicolon in your program. Okay, so if you have not understood my question, I want you to use this printf and print something like CPP nuts like this, but I don't want you to use this semicolon. Okay, after this.
This video is sponsored by Dev C++, a fast, portable, simple and free C and C++ IDE and code editor for Windows. Dev C++ uses MingW GCC as its compiler, and it can also be used in combination with Cygwin or any other GCC based compiler. Dev C++ have low memory footprint because it is native Windows application and does not use Electron. And it is immensely popular due to its light footprint, yet giving you all the features you need, not to mention that it's free. So download the latest release for free by clicking the link in the description field.
How would you do that? If I will run this code, it will say that expected semicolon. So think about it and think hard. I think you have got your answers, so it might be a little shocking, but you can print it like this. Okay, so what you did, you included that printf inside if. Okay, and this is the starting in the end curly braces. So if you'll run this, your answer is CPP nuts, and it is working. Not only if, you can put inside while as well, like while printf and CPP nuts. Okay, and here is the opening and closing bracket. But the problem with the while is printf returns how many characters it printed on the console. So it will be printing 7 characters. So printf will return 7 inside while. Okay, so 7 will come here, and that is not a 0. Then while will run again, and this is empty while, so nothing will come here. It will keep on running. So if you want to see that, let's run this program. See, it is running in infinite loop. Okay, so to solve that, we will put one negation here. Okay, so if you will keep this one, whatever the non-zero value will come, if you are keeping this operator, it will become a 0 value. Okay, means everything except 0 is true in our programming, even if it is minus value or whatever the value is. But if it is 0, then it is false. So this will make it 0 or false. So if you will run this time, it will print CPP nuts, CPP nuts. Okay, so this is the way of printing anything without using semicolon. I know this is really very small question, but knowing these tricks will include so much of knowledge about how things work. Okay, so you might be able to mold this thing and use somewhere else. Okay, so thanks for watching, and let's look at the next question.
Hello friends, this is Rupesh and I'm watching CPP Nuts video series on C interview question, and in this question we'll be looking at designated initialization. So I'm sure lots of the people would have not seen this. So let's suppose someone is asking you, just create an array like this of maybe 10 size and initialize only 3rd and 6th position with some value, maybe 10 and 20. How would you do that? So you might be going like 0, 0, 0, 3rd location 10, then 0, 0, 0, like that you may go. Okay, but there is another way, and that is called designated initialization. So you wanted to initialize 3rd location, right? So 3 is equal to what value you wanted? 10, and another is 6th. So 6th is equal to, let's call it 20, and you are done. What you did, you initialized 3 with 10. I mean 3rd location, there are 0 to 9 location here because we have 10 size. So 3rd location means 4 location is initialized with 10 and 7th place is initialized with 20. So let's check that. For that I need a for loop. I is equal to 0, I less than 10, I plus plus I. Printf arr of I. Okay, and let's define that I. So I'm just printing this 0 to 9. Okay, just to verify that. So let's run this. GCC designated initialization, compiled and running, and see this is the values 0 0 0, and at third location, mean fourth place, it is 10, fifth and sixth is again 0, then 20. So see, you have successfully initialized only third and sixth position. And not only this, you can initialize 6 here and 3 here. It is not required that it should be in order. Okay, you can do this also. So let's compile this and run this again. See, it is giving you the reverse output because we are initializing 10 at 6th and 20 on 3rd. So 20 is coming here and 10 is going here. Not only this, you can do this with structs also, like str, and let's have some a and integer b, and let's comment out this code for now, and we will create str variable s is equal to, now here you can do this, a is equal to, let's make it 10, and dot b is equal to 20. Okay, and yes, it is possible. You created s variable of this structure type and initializing a with 10 and b with 20. So if you want to verify that, you can just go ahead and print this d as dot a and b. So GCC designated initialization and run this 10 and 20, no problem. And again, you can swap the order here, like b can come here and a can come here, no problem, as you was doing in array. So let's again compile this and run this. See, so this is the use of this designated initialization. But stop here. This facility is little restricted in C++. Actually, till now I was talking about C. Okay, don't miss that part. I'm compiling with this GCC option with C compiler, not G++. Okay, so this facility is little restricted. And what do I mean by that? So if you will compile the same code with G++, then it will throw you the error saying that sorry, unimplemented non-trivial designated initializer not supported. What it is trying to tell you is you have swapped the value. I mean, B has come to the first position and A has gone to the second position. So this is not supported. A should be here and B should be here. So if you will compile this again, and this time it is telling, okay, yeah, if it is C++, you have to return integer here. Okay, don't miss that. Now compile. Yeah, see, it has compiled. If you will run this, it is running 10 and 20. So C++ don't allow swapping. Okay, swapping means the order of declaration, I mean whatever the order you have used in declaration should go here. If it is A, B and let's suppose character C, then that C should come after B. Okay, so it should not be unordered in C++. So order has to be maintained. And you might be thinking, what about this array? So you are correct. Array is also restricted. So let's check that as well. So I'll comment this code here. No need of this one. So let's look at this. As I was telling you, this is a valid code in C. So let's compile the same code in C++. It will throw the error saying that it is not allowed. So it's not telling that 3 should be here and 6 should be here. It is telling that all the members should exist. Okay, so let me show you that. If you'll make 3 here and 6 here and we'll go and compile this, still it will give you the same error. Okay, so it is telling that you need to have all the 10 members initialized like this. And to prove that, let's make it little smaller here. Don't make it too big. And let's make it 0 and let's make this one 1. Now this is 2 size and we are initializing 0 and 1 position and going from 0 to 1. Okay, so let's compile this one and it will compile. See, it has compiled. If running 10 and 20, so everything is good here, no problem. And here you cannot swap the order. So let's verify that as well. I don't know why C++ is not giving this. If you get that, please let me know. I'll be very happy to see that. So see, it is again the same problem. So order has to be maintained. Got it? So that's it guys. If you learned something new today, don't forget to hit the like button and subscribe my channel for videos like this. I'll see you in the next video. Bye bye.
Hello there. Today's topic is a to I function. So this is a function. Okay. This a means ASCII. 2 means we will be converting to an integer. Okay. So we will be converting ASCII to the integer. And this is a function already given in the C and C++ language. So let's see first the use of this function. Then we'll go and create our own function of this type, because lots of interviews ask you to implement a to I function. Okay, so the use of this function is it will convert your string into an integer, but that string should contain the numbers like 1, 5, 9, 0, 8. Okay, like this. So this is a string. If you will convert this into integer, it will still look like 15908, but this is integer part, so you can now apply any addition, minus, multiplication and all those arithmetic operation on this. Okay, because this is integer. Okay, you cannot do all those things here because this is a character pointer. Okay, so we want this to this. Generally we get this because when we are dealing with websites and web development cases, if you are passing something from website to your C code, everything generally comes in a string format. Okay, so you have to convert it into the integer format and you have to use that. That's where we use this a to I. That's what I can recall where I use this. Okay, so this was the use of ASCII to integer function. Let's look at the code for this. So this is your code now. As you can see, we have this particular string, and yeah, I forgot to mention that string could be a minus also. Okay, so this is minus 1 2 3 4 and this is a character array. We will pass that character array to my a to I function. Okay, so this is the code for converting your character pointer into the integer. Okay, so these are some variables we'll be using. So this, ultimately this is our result, this is our sign bit, and this is the index what we are currently pointing to that character array. Okay, so these are just simply initialization. Now let's come to this point. If your input is minus, then str's 0 position will be holding this character. Okay, so 0th location will be having this particular character. Okay, so yes, it is true. So we will do sign is equal to -1 and we will increment our pointer of I. So now we will be pointing to the next location. Now I is 1 and we will start from 1 until unless we get the null. Okay, and this is a very basic technique we use to create your integer from your character pointer. Okay, the only thing you have to take care of is this one. Okay, you are taking the character and minus character 0. This is the key to convert your string into integer. Okay, so let me explain this little further. If your string is like 1 2 3 and at a time you will be picking 1, so this is like this, 1 minus 0. Okay, and this will produce 1 and this is an integer 1. Okay, how this is happening? Actually you are not doing this character minus. Actually this 0 is 48 in the ASCII and this 1 is 49. Okay, so 49 minus 48 will result into 1. Okay, so if your 0 is a character, this 1 2 3 4 5. Okay, so this is an ASCII value, this is the character. So if you will minus 0 with any of the character, you will get that difference only. That's why we do this. Okay, so this is where the character will be and you will do the minus of 0. But don't forget, this 0 is not simple 0, this is a character 0. Okay, so if your I is 1 and your string which is passed is this one, like minus 1 2 3 and 4, then your I is pointing to this location and initially your result is 0
0 into 10 plus stri, which is 1 minus 0 will be 0. So your result will be 1. Okay, in first case. Then we will increment our I. We'll go back inside this. Now we are pointing at 2. So it is going to be 1 into 10 plus 2. Okay, 1 is because this res is updated, right? So new value will be this one, res is equal to this one. So it is going to be 12. Okay, we do this trick so that your number will get incremented, okay, by digits. You are just including one more digit into that. Initially it was 1, okay, then it has to be 12, right? 12 is nothing but 1 into 10 plus 2. Now if it should be 1, 2, 3, then currently if it is 12, you have to multiply it by 10 to make 1, 2, 0, which is 3 digit. Now you add 3, so it will make 1, 2, 3. Okay, so this is kind of a trick we use to increase our integer by digits. Okay, and just simply this will add the number inside that and we will get our integer. Okay, and lastly we are multiplying the sign bit. I mean the sign, if it is -1, it will become minus, the result will become minus. If we didn't went inside this function, let's suppose this minus is not there, then we will not go inside this function and just simply hold 1 here, and 1 into something will result into the same number and we'll return that number. Okay, so let's quickly see the working of this one. So if this is the code, first let's compile the code. See, you have got -1, 2, 3, 4, and see, I'm printing value here. Okay, and let's suppose you are having some another string like this. We are getting into value 1 and 2 and we're just printing the addition. So it will be 5555, but -555. Okay, and if we are keeping this one as positive and this one as negative, the result would be 3087. Okay, that's it. So I think you got the point here. The main thing was just to remember, if you want to convert any character, like this is a character, right? If this is a character 1, you want to convert it into integer 1, just do this minus with 0. Okay, and now if you will store it in some integer I, that I will hold the integer part of 1. Okay, because we have this ASCII value like this, and we do the minus of this one with this one, we will get the difference as 1. Okay, so that's the trick and nothing more to understand this. This function and all can be implemented in any ways. We have not included any check here, like if your string what you are passing is holding some non-integer value. Maybe if your string is holding like this is like 1 2 k 3 c. Okay, so if you will try to convert this one into string, that string will not be perfect because we are having k and c here. Okay, this is 3, so we have to check that also, but the main point was how to convert that, and this is the way of doing that. Okay, so thanks for watching.
Hello friends, in this video we'll be learning about what is big indent and little indent. So notice this is indent, not Indian. Okay, lots of people do this mistake. So what is this big indent and little indent? Big indent and little indent are two techniques to store the data inside your RAM. Okay, so this is your RAM 1 and this is RAM 2, and we are using big indent to write your data inside this, and we will be using little indent to write your data. And this is your data. This data is in hex form. Okay, 0 cross, don't miss this part. Okay, so I'll show you how this is stored in your RAM. This is your RAM and this is the address, and this is also the address. So if it is big indent, in that case the data is stored from lower to higher. Okay, see, this is 0 cross 20, this is address 0 cross 21, and yes, this is 1 byte address. Okay, so this is a 1 byte area and we are addressing that. Okay, and this whole is a 1 byte address, and your memory is 1 byte addressable memory, your RAM. Okay, So whenever you get some address, that address is pointing to a 1 byte. Actually, if you are 4-byte data, like if it is integer pointer, then in that case, and it is pointing to the location, and let's suppose this is 21, then this 21 means the first byte of the integer pointer, I mean 4 bytes. Okay, so your address is always pointing to 1 byte only. Okay, so that is not the point. The point is, big Endian stored data from lower to higher. Like if you are storing hex value is not a decimal value. If it is hex value, it will be like 0000 for 0. Okay, hex means 4 bits. Okay, so this particular 0 will take 4 bits, this one will take 4 bits, like 0 0 0 and 1, and this is 1. So this is decimal and this is hex. Okay, so if you are going to store this number inside your RAM, it would look like this. First, these two numbers will get stored. Okay, why 2? Because this is 1 byte, and 1 byte means 8 bits, and 0 and 1 both are having 8 bits. Okay, so it will start from here, like it will take 0. Okay, 0 means 4 times zeros, so it will fill 4 times zeros. After that, okay, it will see 1, then it will fill 3 zeros here and then 1. Okay, so like that it will fill. And this seems to be a pretty obvious case, but in Little Endian it is reversed. Okay, so if you want to store this particular data inside Little Endian system, yeah, I need to tell that there are computers Little Endian and other computers follow Big Endian. Okay, so if your computer is working on Little Endian system, it will be considering this memory type. Okay, as I said, Little Endian start from higher to lower. It will take this one first, and yes, don't miss that. Even if it is going inside reverse order, it will be in this order when it is reading this particular byte here. Okay, it is not like it will read first 1, then 0, then 3, then 2. No, if we are talking about this particular area, first it will read the first byte of that, then second byte, then third byte, then fourth byte, and like that. Okay, so it will go in this direction when it is reading the particular memory area. Okay, but it will store in this direction. Okay, so that's why 0 and 1 was stored here. After that, 2 and 3, 4 and 5 and 6 and 7. Now people ask these questions like, which is good, either this one or this one? But it is like both are good. This Little Endian and Big Endian is derived from some novel or something. I don't remember that exactly, but this is like this. If you have an egg, that egg look like this, and you want to cook this egg, so if you are breaking from top, then also your egg is getting broken. And if you are not breaking from top, if you are breaking from bottom, then also it is broken. Okay, so there is no exact point of discussion in breaking egg either from top or the bottom. So in that case, this also implies similarly, like Little Endian and Big Endian both are having their own way. It goes in this way, this one goes in this way, and it really doesn't matter much because your whole system is in this way. Okay, so there is no extra conversion happening in between your program and your RAM and your processor. Okay, and the same for Big Endian also. But the problem happens when you are transferring some data in network and your data is coming from Little Endian and you're receiving in Big Endian, or vice versa. Okay, so there comes the problem. So we need either side the converter to convert that. If it is Big Endian, it will be converted into Little Endian and vice versa. Okay, so now let's look at the program, how to find your system is Little Endian or Big Endian. Okay, so I have this simple program here. I have taken this unsigned integer I is equal to 1, and if you know that integer will take 4 bytes, so let's quickly create that. And if this is Big Endian, I mean, if our system is beginning, in that case, I told you our value, this 1, will get stored in this fashion. Okay, so let's store that. 1 means 0 0 0 0 0 up to 31 time, and lastly you will have 1. Okay, so if you are converting a decimal 1 into a binary 1 with 32 bit, it will be looking like this. Okay, so let's put that here. 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 1. Okay, so this is binary, and if this is little Endian, then it would look like this: 0 0 0 1 0 0 0 0 0 0 0 0 0 0 0 0 0. Okay, so notice this byte is starting with 0 0 0, and in last we are getting it 1. Okay, so this is like 0 0 0 0 0 1 in 1, and rest are zeros. Okay, if it is little Endian, and that address, let's call this address is like 0 cross 21. We are typecasting that address into a character pointer. Okay, so this whole 4 byte will get typecasted into character pointer. Before we were having it like integer pointer, now we are pointing with character pointer also. Okay, so character pointer means it will point to a 1 byte memory. Okay, sorry, this is bit, 1 byte is this full. Okay, now if you will check if the value at that pointer is non-zero, means if C has some value, it means it is little Endian. Okay, see, it is not having any value, it is 0 0 0 0 0. So 8 times 0 is a 0 in decimal. Okay, but 0 0 0 0 0 0 0 1 in decimal it is 1. Okay, so here we are getting 1, but here we are getting 0. That's why if you will run this program, it will be printing little Endian. Okay, because my computer is a little Endian, I know that. So let's quickly run that. See, it is printing little Endian. Okay, so that's it. If you have any doubt, please comment. I'll be very happy to explain that. Okay, thanks for watching.
Hello there, this is Rupesh and you're watching CP Peanuts video series on C and C++ interview questions. And in this video, we'll discuss how to return two-dimensional array from function in C and C++. So there are basically 3 ways to do that. First is using dynamic array. Second is using a static keyword. You will be creating the array statically. Okay. And third is using a struct technique. So we'll discuss one by one. So this first one is using this dynamic array here. So how we create dynamic array, 2D dynamic array, that's the whole technique here. So this is the whole program. We have this main here. Main is having this double integer pointer. We are calling this get array function. This function here, we're creating 2D array like this. So I'll tell you what is the meaning of this line here. This line here is telling that, okay, I'll be creating n number of integer pointer array. So n is nothing but 3 here. So we will have 3 pointers. Okay, so this will store integer pointer, the address of integer. Okay, and after that, using this for loop, we are iteratively inserting integer of n's. So integer of 3. So this is like this. You have this 3, this 3, and this 3 arrays here, and you are putting this inside this. The initial address of that. Okay, so this is what happening here. So this line is creating this one, and this line is responsible for creating this one, and this one. And why it is creating 3 times? Because it is in loop, and we are running from 0 to n, which is 3. Okay, that's why it is created 3 times. So this is how we create a 2-dimensional array dynamically. So when you will access it like this, array of I, let's suppose this is 0th here, this is 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. Then in this case, if you are accessing 0 means this one, and 0 means this one. So if it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 0 means this position, because first 0 is this one, second 0 is this one, so this is 1. If it is 0 1, then first 0 is always this one. If it is 2 1, that means 2 means this one, 1 means this one, so it is 8. Okay, so like this whole dynamic array creation work. And why this dynamic array thing will work? We are creating this as a pointer, and we know that pointer doesn't get created on the function stack. The real problem we are dealing with array returning is, if you are creating array here in this function and returning that, we don't return the array, we get the address of that, and once this function will get destroyed, that array will also get destroyed. So if you are not sure what I'm talking about, please go and watch my previous video which tells that how to return one-dimensional array. There I have explained what are the complexities in returning arrays. Okay, so this is one of the way here. I think this whole code is pretty much clear because I have written in such a way that there won't be any issue. Okay, so this is the function call here. You are calling this function, you are creating the array. First line will create this one, and these for loops will create this one, and this for loop will fill the data inside that. Okay, so it doesn't matter what data you're filling, and after that you're just returning that array, okay, with this double pointer. And this is the syntax of doing this. Okay, so let's compile this and check whether it is compiling or not. See, it has compiled, and the answer is 0 1 2 1 2 3 and 2 3 4. So this is what I inserted inside that, so that's what we are getting here. And if you are watching for C, just replace this line with printf. Okay, printf d array of I j. Okay, and you're done. There's no issue in this, and you will have to remove this using namespace in iOS stream, but the code will be similar. Okay, there is not much change. You won't be having this return 0, but that also doesn't matter. The whole idea is, from where you want to return the array, create it dynamically, and this is the way of doing this. Note it down. Okay, so let's move to the next point, which tells that using static keyword. So let me replace this whole code here, and this is the code for that. And this is something you might find a weird one. Okay, we are doing everything similar but not exact similar. Before, if you remember, we were having this as a double pointer, but this time if you really want to get return an array, not as a pointer, and please remember, arrays are not similar to the pointers, so they are total different things. Okay, so before we were dealing with the pointers, that's why we were returning double pointer, and that was making sense, and everywhere we were using double pointers and things was good. And this time we'll be dealing with the arrays. You will be returning array, literally array. So this is what the syntax is. And if you want to get array into your pointer, this is what the syntax is. Okay, so this is how you will create a pointer which will hold n number of arrays. Okay, and this field has to be there, and this should be a constant value. Okay, so this is how you do this. Get array will do the same thing. Get array is this function, and yes, this is the syntax of writing your function which returns 2D array. It is looking very weird, but it is really very simple. But there is a technique, type def. There you can use, define the type. Like suppose you are defining a type like double pointer. Okay, and this is what it is. After this, you have to keep this one as a type. So now your life will become easy. Okay, and you're done. See, compile this, and it is working fine. Okay, so what you did, you created a type by saying that, okay, this is a pointer of an arrays. Okay, and why static int is working here, I have already discussed in previous video that the static is created at global scope and it doesn't get destroyed when you return from this function. Okay, so it will be there. That's why you are happily accessing here. I recommend please watch my previous video which tells about how to return one-dimensional array. There I have discussed so many things, and that would be clearing your doubt so much. And the last one is using struct technique. So let's look at that. So this is what the struct technique is you will be wrapping your array, whatever you want to return from some array, inside some structure, okay, like this, and just simply create the variable of that structure type and fill that array and simply return that variable and keep that type as a structure type. And that is perfectly fine because here it is written by a value. Okay, so array element will get copied one element by one element here. Okay, you can do this with classes also. I have taken struct because maybe those people who don't know C++ might get confused here. Okay, so this is the third technique. Let's compile this and check the working of this one. Yeah, see, this is also working. Okay, so this is really very simple. You are creating a structure, accessing that array inside that and just populating it and just returning. After that, we are just simply getting it, sending it to print. We are printing it. Everything is okay. So this is one of the coolest way to do this. But when your array will get bigger and bigger, then this return here will make problem for you because it is a copy of your all the elements from this variable to this variable. Okay, that's why generally we don't prefer this, and we don't really use this returning array thing. We generally, what we do, we create the array here itself and we'll send the address of that here and we will populate that array here. We don't create array and populate here and just return that array. No, we generally don't do that. So this is all about returning two-dimensional array. Thanks for watching. Hello guys, you're watching CP Peanuts video on function pointer. So we'll try to answer these questions here, like what is function pointer and how to create them, and calling a function pointer using a function pointer itself. And last, what is the actual use of function pointer, where we should use function pointer, not anything else. Okay, so stay with me and let's start it. So first of all, what is function pointer? So I have these questions and answer here. So as we all know that normal pointers variables store the address of another variable. Okay, so if you are writing something like this, integer I and integer pointer p, so this pointer p will hold the address of I. Okay, so we all know that very well. Okay, now what is function pointer? If it is function pointer, it will be storing the address of another function. Okay, so first you remember that. Now the question is how to create them. So we'll take the example of this normal pointer itself. So let's suppose you have some function which will add two numbers and return the addition. Now you're going to create a function pointer which will store the address of this add. Okay, so how do you do that? So let's take an example of this one here. You wanted to store the address of I, so you created integer pointer. See, you didn't create a character pointer and stored the address of I. No, you did this. Okay, you created integer pointer and stored the integer data type's address inside that. Okay, so if you want to store this type of address, then you have to create this type of pointer to hold this address. And what do I mean by that is the function pointer what you are going to create should return integer and should take two integers like this as a parameter. And it is really very simple to create function pointers. Why? Because what you did in case of normal pointer here, you just created a variable and at front of the name you just put this star mark. Okay, so we'll do the same with function. Let's suppose you have this function name and it is returning two integers, and you will write this pointer at front of this function name. But hold on guys, this is not done. If you will see something like this, what would you think? There is a function. That function is taking two arguments as integer and returning integer pointer. It is looking like you're returning integer pointer. This is not looking like a function pointer. So this star or asterisk should be with this name. So how to associate this? This is the way. And you are done. Now it is function pointer. And you can happily assign this add here. Okay. So let's see whether this code is really a working code. So this is your program. This is the add function. And we are creating a function pointer here. So let's compile this. So this is GCC. Program name is demo. We compile it. There is no issue in this program. Okay. So what we have learned is how to create a function pointer here. Okay. So what it is doing actually, it is holding the address of this add function. And there are two ways to do this. I mean, I just literally forgot to mention that, but I should mention that as well. There is this way of assigning the address of A, and this is another way. Okay, so this is most perfect way because this will work even with the old compilers. This is not going to work with old compilers. Okay, so better you should always use this one if you want to migrate from new compiler to old compiler. Now, as this add is here, now you can use this function to call this function. That's the only thing what this function pointer is meant for. Okay, you will be calling some function with some another name. Okay, so you're calling this add function with this function, and let's see how. So if you want to call some function here, you just simply pass these two values. You will get some value like C here, and we can just simply go ahead and print that. So let's compile this code. There's no problem. If we'll run this, the answer is 3. So 1, 2, and 3. So you notice that your function pointer thing is working. But wait a second. This is a new way to call function. And this is the traditional way. Okay. So I told you how to assign that by using address operator, and how to call function. There was that simple way, and this is the traditional way. So let's check this out, that this traditional is working. And yeah, see, it is working. Okay, now we know how to create function pointer, and we know how to call them. Okay, and as I told you that your function pointer should be of type exactly what you are going to assign in that. Okay, so this add is of type returning integer and taking 2 parameters. That's why your function pointer is also returning integer and taking 2 integer parameters. Okay, so if you will make some change here, let's suppose you are adding one extra integer, in that case, if you will compile, there will be an error. Too few arguments to function fun. Okay, and if you will add another argument like 1, 2, 3, and you will go and compile. So here you got the warning because wait a second, and the result is 3. So this is what I wanted to show you, that if your pointer is of not the same type what you are assigning into that, is a problem here. Okay, see the warning here. So you should avoid using this, because see, this third value is avoided here. Okay, only 1 and 2 are passed, and you are returning is the addition of 1 and 2 here. Okay, so far we have learned about function pointers and how to create them. Okay, now there is another question, and that question is this calling a function using a function pointer. We already saw this, so we will skip this question. Now there is this another question: how to pass a function pointer as an argument to another function. So let's create another function here. So let's try to understand what is happening here. You have one function, function1, and you're passing this add, which means you're passing the address of this add function to this function, and you're catching that address like this. Okay, so this is how you write in function parameter when you are getting some function's address. Okay, so let's run this. If you will compile this. Okay, I forgot to have this C here. Okay, so let's compile again. There is no issue. If you will run this, answer is still 3. Okay, so this function we are calling add function here with some function name, and that some function is getting created like this. Now we will see another question here, and that question is how to return a function pointer. And this is really very interesting question. It was so easy, right? What function type you want to return? These both functions prototype is same. I mean, both are taking 2 integers and returning 1 integer. So you created a type of the same prototype here. Now let's look at the another one. That another one is little tricky. Let's suppose you don't want to use this type def and all, then how you will deal with this? So this is your function which will return a function pointer of this type. Okay, so let's do that. And this type is returning integer and taking two integers. So first of all, you will enclose this function with one round bracket here like this. So this has become the name parameter, integer and integer, and the return type was integer. And one more thing, this pointer, and you're set. Now there is this function fun which returns a function pointer of type taking two integer as a parameter and returning one integer. Okay, so this is how this whole thing will work. So let's compare whether it is working or not. So it is working, and the answer is still 3. I know this is little tricky and hard as compared to this type def thing, and that type def was more readable than this. Okay, so if I will remove all that, see, this function is a function which will return this math function type. Okay, this is a type, not a function. Okay, don't get confused. You always write type here like integer and character. Okay, so if I'm writing this math function, that means it is a type, and we are defining a type like this using type def. And the syntax to define a function pointer as a type is this. Okay, I know this is a little bit hard to understand, but once you will practice 2-3 times, like pass some function and return some function and try to do all those things what I taught you here, it will be a little easier for you to remember all these things. Okay, so we have seen how to return a function pointer. Now there is a question which says how to use arrays of function pointers. So now I will create arrays of functions. So see, this is really very easy, right? That you are creating an array of two size, and the type of that array is math function, which is nothing but a function pointer, return integer, and take two integer as a parameter. Okay, that's why we are assigning these two functions of this type into the array. Okay, and this is the syntax of calling that. And yeah, this is new syntax actually. You should call it like this, and this pointer and this pointer. Okay, so let's compile this as well. There's no problem, and the same answer. Okay, now this was a very neat and clean way to create an array of function pointers, because you have this type created already using type def. What if you are not using this type def and you want to create an array which stores these two functions of type this? In that case, you will again do the same thing. You will wrap this, put this pointer here. Now you do integer and integer comma integer. What we did before, I told you to wrap whatever that function was when we were learning returning a function from another function. I mean, returning a function pointer from some another function. That time I told if you're not using that type def, then you will be wrapping up your function and write the type like this. So here you wrapped up your array with this pointer sign and return type like this. Okay, and now we're good to go. Let's compile this. This is compiled and running. It is working. Okay, so now you're not using this type def thing and all that, but I would recommend using that because that gives a code readability. This is so much confusing, right? So we have seen how to create an array of function pointers. Okay, like this. Now let's look at the next question here, and that question is where to use function pointers. This is really very important question. So I have a program for that, and the best use I can say is you will pass your function's address, okay, to some another function, and there you will use this function, okay, or any function you want to use. So the best use is in C, we know there is something called qsort, which is quick sort. This is inbuilt function which will sort your array. So let's suppose you are having some array, you will pass that array inside this qsort, and this qsort will sort that array. And there are a few parameters you need to give. And lastly, you have to give the address of your function, which will compare the elements. Okay, so qsort need a function to compare two elements. Okay, so let's run this and find whether it is really working or not. So this is GCC demo, and now if you will run this, see 1 2 3 4 5. So you give this array in quicksort sorted out the elements inside that with the help of this compare function, and after that we are just simply printing the whole array. Okay, and as I told, this is making the ascending order. If you will make like this, like left hand side is less than right hand side, and then if you will return true, then this will become descending order. Let's compile this and check this again. See, first it is printing 5 4 3 2 1. Before it was 1 2 3 4 5. Okay, so we can clearly see that this is playing a major role here, but that is not the point. The point is qsort need one function as a parameter. Okay, this function is a user defined function, this compare function, because sometimes what happens, you are sorting some structure. This is integer value, so it's okay, but let's suppose you're sorting some structure or something, then in that case you will be passing two structure pointers. You will typecast that into the structure, and inside that structure there would be some field. On that basis you will be sorting that whole structure. Okay, I mean array of structures. So in that case this compare function becomes really handy. So that's the only reason this compare function is given to us. I mean, we are supposed to implement this function. The rest of the things are taken care by this qsort, but the compare thing is given to us. Okay, because our data could be anything. It could be class or anything. Okay, so to recap that, the best use is you will be passing your function according to your need. This is really very good example to understand this. Okay, so I think you got the video. If you like the video, don't forget to hit the like and subscribe button if you haven't subscribed yet. I'll see you in the next video.
Hello friends, welcome to another C++ interesting interview question. And the question is, why malloc is faster than calloc? Or you can say, which one is faster among these two? And the short answer is, malloc is faster and the calloc is slower. But actually it depends. And why? Because malloc returns memory as it is, it gets from OS. But when you call calloc, it gets memory from kernel or the OS and it initializes it with 0 and then it returns to you. Okay, so that initialization takes time. So that's the reason calloc is slow. So there are few points you should always keep in your mind when you are going to use malloc or calloc, or you should say when you should use malloc instead of calloc and the vice versa. And the point is, you should not use it like this. It means you are getting the memory from the kernel and you are setting it with 0. You should not explicitly do this. You should just use malloc for this purpose. Okay, if you want some memory and you are setting it with 0, and then you will start using it somewhere here. Okay, here. So you should not do this. You should always give this calloc call for that purpose, because the reason is calloc does internally some optimization which this malloc doesn't do. Okay, so I won't tell what those optimization is, because that would require so much of paging and framing knowledge. This much knowledge is more than enough for this question. So we are done here. Thanks for watching, and make sure you like and subscribe so that you will get the notification for upcoming videos like this. Bye-bye.
Hello friends, welcome to another C++ interview question, and the question is, what does printf and scanf returns when they get executed? Okay, and you might be thinking, how does this become C++ interview question? They can ask any question which is related to C also. Okay, so they can just check out your knowledge and the basic knowledge. Okay, so and the answer for this question is, printf return the number of characters printed successfully on the console, and scanf return the number of elements read successfully from the console. So we'll check out what is that. This array is nothing but one array of characters of 100 size, and this is printf and scanf, and this is I'm getting the output from printf, and this is
the output of scanf. So as you can see here, whatever the output would come will go here, and whatever the output will come from scanf will go here. Okay, and at last I'm just printing that. So we'll just go ahead and just run this code. We compile it, we'll run it. So this is printf. It will be printing this hi there, and after that it is waiting for the console to for me to input something. Like I will just say something like Ethan or something. In first case it is giving you 11, and second case it is giving you 1. Why 11? Because this is whole 11 character string. Okay, and why scanf is giving you 1 only? Just because we are using only one element here. Okay, if suppose I'm using something like this, well here and percentage 30, then in this case it will give you different output. So we'll see here again Ethan, and now another value for this. So let's say 10. So now this time it will give you 100 and 2. So that 100 for hi there, and 2 for how many elements you are using, getting from the scanf. So that is for 2. So that's it. I'm done here. Thanks for watching, and make sure you go and check out my playlist so that you will get the videos like this. Bye bye.
Hello friends, welcome to another C++ interview question, and the question is, what is dangling pointer in C++? Okay, so this is one pointer. I have created dynamically memory for that. So first of all we will not initialize anything. Okay, this int is the size of the memory it is going to create. Okay, so this is done. After that, and then you are assigning this p1 to this p2, and after that you are sending this p2 to some function, which is this function. Okay, after that you are getting this pointer, and I'm just printing it. Maybe you might be doing something world changing things here. Okay, after that you think that okay, now I don't want this pointer anymore, I will delete this, and by this mean you want to delete this p2 here. Okay, so you thought okay, it is not, p2 is no longer required here, so you will just delete that. After deleting this p2, you came back from this function and you started using this p1, because you didn't deleted this p1, you only deleted p2. But stop there guys, you copied p1 into p2. Okay, after that you are deleting p2 here, which is this ptr. In that case you are ultimately deleting this p1 also. Okay, so this is what the dangling problem is. Okay, you mistakenly delete some pointer and still you use that pointer. So after coming from this function here, you'll keep on using this p1 here, which is an undefined behavior. Okay, some people say that it is not undefined behavior, but it is an undefined behavior in some cases. Okay, or in almost all the cases. So we'll run this program and we'll check the output here. So we can just simply compile and run. So 0 0, and initially we can just simply assign this with 100 to some value. After compiling this, yes, you can see here, after copying here, we are printing this here first. Okay, so this function is getting called and you are printing this 100 here. After that you delete this pointer, you are coming back, and after that you are printing this p1, which was originally holding this 100, but that is printing you 0. That means that memory is freed, but still you are using that. So that is the problem. Actually you get 0 here, but maybe your memory can crash or something. Okay, so anything is possible. Here it is not crashing, but it can crash. Okay, so this is dangling problem. Thanks for watching, and check out my other videos, and if you like the video, please like and subscribe. Bye bye.
Hello friends, welcome to another C++ interview question, and the question is, what is segmentation fault and how to debug that? So the segmentation fault is nothing but the memory related problems, like you are going to access some memory which is you are not allowed to access. Okay, so these are the examples of that, like stack overflow. This is not the violation actually, but you are asking some extra memory which your CPU doesn't have. Okay, so in that case the segmentation fault comes. You are going to write somewhere which you are not allowed to write. Okay, so that time segmentation fault comes, and you are going to read from some location from where you are not allowed to read. Okay, so at that time also this segmentation fault comes. So this is a typical example here. We are going to assign this null into this integer pointer, and if you will assign this 10, that means you are going to dereference this null here. Okay, so that is a segmentation fault. So I'll show you the example how it looks like when it runs. Now we'll just simply compile this. So its name is app.cpp. Run this. It will tell segmentation fault. Okay, so your program always tell that you have segmentation fault, but it never tells where it is. Okay, so let's suppose you are having thousands and thousands line of your code. You might end up checking each and every line by debugging that where it is getting this segmentation fault, and sometimes it is input dependent. Like sometimes if it is random, then you really struggle so much to find that. So there is a solution for that. We can just simply use the GDB. I will explain how to use GDB in one of my previous videos. So if you don't know how to use GDB, you can go and check that video. Okay. So if you will do this ls, your code dumped file, this file has created. Okay. This file is nothing but the image of your process where it is dumped all those data, like when it got corrupted, what was the image of your process. Okay. So it creates this image so that you can just simply debug through this. If you will see this image, you won't be able to understand anything. Like, see, this is totally not readable code, but there is a way. This GDB will help you with that. Okay, so GDB a.out, your executable name and this core name, and you will hit enter, and then simply run this. Oh, sorry, I just forgot to compile. You need to compile with G++ minus G option. Then only this will show you where this program is failing. Okay, so in order to get the proper line where this segmentation fault is coming, you need to compile this with this G option. I forgot that, so that's why it was not showing. Okay, so now if you will see again, it is telling you the code dump file is created. Now we will do this GDB a.out and core and the enter, and you just hit the run button here. It is telling you at this line we are failing. Okay, 15 number in app.cpp. Let's suppose you are having 10,000 files, then it will tell you that which file is responsible for your segmentation fault with the line number. Okay, so here you are dereferencing this null, that's why it is causing you the segmentation fault, and this GDB has directly tell you that where is the problem. So this is how we debug the segmentation fault. Okay, this is you can tell the problem is you are accessing some area which you are not allowed to access. Okay, this null you cannot access a null. Okay, but as I told you that there is a problem with stack overflow also. To get that error, we can just simply call ourselves. Okay, so in order to get that, we can simply call ourselves. So I'll just compile this code again. Okay, like GDB, and we will try to run this. It will tell you the same error. Segmentation fault has come because your main is calling itself again and again and again, and sometime it is going out of memory, so it is telling you segmentation fault. Okay, actually if you guys don't know how this recursion works, whenever you call some function, some stack is created, and to maintain that stack information you need to have some extra information like stack number or something. Okay, so that is also taking so much of memory. So in that case, when you create lots of stacks, you go out of memory. Okay, so this is what happening in here. So you are going out of memory. That's why this segmentation fault is coming, because somewhere someone is trying to increment some variable and trying to access some memory which is not there. Okay, so that's why this segmentation fault is coming. But you always try to remember all the time everything is related to the memory only. Okay, so we will try to debug this also. I will just do the GDB, our executable, and the code, and you just simply hit the run button. It will tell you you are getting segmentation fault at this line, at 14th line, so you can verify it here. Okay, so I think I'm done here. Thanks for watching. Bye bye.
Hello all friends, this is your first program. If you know already, please watch the next video. So the pattern is, if you don't know what is the pattern, I'll just tell you. The pattern is, I'll tell you to pause the video, I'll count till 5 and you need to pause the video, and after that I will explain the concept here. Okay, so I'm going to count till 5, you pause the video and try to understand what is happening here. So 1, 2, 3, 4, 5. I think you would have paused your video by now and maybe you got the answer. So let's look at the answer now. At least compile error is not there. So let's go ahead and run this. So the answer is hi there 8, which is this one. Yeah, last one. Okay, so this is the answer for you. So we'll try to understand this, what is happening here. So we all know there are two function calling here. One is printf, another one is again the printf. So first this printf will be called and it would call this printf. Okay, because generally what happens,
if you have written something like this, function, and inside that function some another function, let's suppose this one, okay, and you're calling this function, but before that this function will be called, okay. So the same thing is happening here. You're going to call printf, but before this printf this will be called, because this printf need some value which this printf will return, okay. So here also the same meaning is there. This function would return something which this function will get as a parameter. So compiler will go and see this function first and will try to call this function, but it won't be able to call just because its parameter is not fixed. So in order to get the parameter, you need to call this function 1 first, okay. So function 1 would get called first. So that is the same scenario here. So in that case, this printf will print this hi there. First it will return how many characters it printed, okay. So there are 8 characters. So the printf always return how many characters it printed successfully, okay. So that 8 will come here, and instead of this thing 8 will come like this, and you will print that 8. So first what happened, you just printed this and it returned 8 like this, and that 8 is printed here. That's why this hi there 8 is there, okay. In order to show you, I'll just increment one more character here like this. So now it became 9. If I will compile this again, see this hi there 9, okay. This is how this printf work, okay, and this is what printf returns. If you want to see what scanf returns, check out the next video. Hi friends, this is another question. If you watched my first video, in that I have shown how this printf work. So first this print will be called, and this printf will end up calling this scanf, okay, because you need a data to print, okay, and data is supposed to come from this scanf. So first this scanf will be called here, okay. So I'm going to count till 5. You pause the video and try to understand that. 1 2 3 4 5. I think you would have come up with the answers. Let's go ahead and check that. So this is 2. Hit enter. At least compilation error is not there. Now hit and run this. So now printf was called, and printf end up calling this scanf, and this scanf is waiting for me to give the input here. So I will just give some input like this one, okay. This will go into P here. Now it is waiting for J input. I will give J input as 10. Hit enter. It is giving you 2 output. That means this C is the correct answer. So what is happening here? Scanf returns how many parameters it got successfully. So I gave 2 parameters here, Rupesh and 10, okay. Or you can say 2 elements, Rupesh and 10. So that's why it returned 2, that I readed successfully 2 elements. That's why it returned 2, and this printf end up printing 2 here like this, okay. Remember this what I told. In order to make sure that this thing is really working the way I am telling you, I will just create another variable here. So we are looking for 3 values now here, okay. So it should come 3, right? P, J and I. So again we will compile this, run this. Again I will say Rupesh. This time I will say my another name, Ethan. This time I will give some value like 20 and 30. See, this time it is giving you 3. That means it read 3 elements successfully. That's why it is returning 3. Who is returning 3? Scanf is returning 3 after reading all these 3 values, okay. And printf is printing just 3, which is coming from scanf like this, okay. So I think we all know how this whole thing is working. So let's look at the next video now. Hi friends, this is your another question. This is very simple question, but if you know this, what is this constant thing is, okay. So I'm going to count till 5. Pause the video. 1 2 3 4 5. So let's look at the answer for this. This is 4 compiled successfully, so at least compilation error is not there. Now we'll run this, and the answer is main. So from where this main is coming? Actually this function is nothing but a constant, okay. These are special constant available in our C and C++, okay. So if you will write this and print it, or you will assign this value into somewhere else, then it will return you the characters. Okay, and there is not only this function. Actually, this function means in what function you are. So currently you are in this main function. So if you want to see something like this, like you are in some another function and you want to print what is that, then you can just simply print this also. Okay, so if you will call it from here, now you will be able to see that it is giving you this function name. Okay, we will compile this and we will check that. See, first it printed main because it printed this one. Then you are calling this function. We are going here and we are printing again the same statement. Now this time this function is this function. Okay, this one. And from here, if you will go to some another function, let's say some other function, then it will give you some another function name, like see some another function. And if you want to print here this one, it will give you some another function. So we can just compile that and see main function and some another function. And this is not done. We don't have only this function thing. We have lots of things like functions. Here instead of function you can just give file. Okay, then it will print what file name is, like 4.c. so we can check that also. Okay, I need to remove this. Compile, run, see 4.c, and this is the file name. Okay, not only this, we have something called date also. Okay, we can compile this, run, so it is telling you the date also. Okay, so answer to this question is main, first one. Okay, so I think we're done here. Let's look at the next question now. Hello friends, welcome to another video of this C MCQ series. I'll count till 5, pause the video and try to understand what is happening here. 1, 2, 3, 4, 5. I think you would have come up with the answers by now. So what is happening here? We are just simply doing the modulo operator on 5.3 modulo division with 5. So generally what we would expect is like this: 5.3 modulo 5 should be 0.3 here. Okay, so this is what we would expect. Okay, so let's see whether it is the expected thing or not. So this question is 5. We'll compile this, and it is a compile time error. We cannot apply modulo operator on floating point numbers. Okay, if this floating point is not there, this is going to work. See, we will compile this. There is a warning. It is saying that you are using this float, whether it is getting integer here. I will just remove this one so that it can be easy to see. Yeah, 0, that is expected. If you will do it like 7 here, we expect 2 as the answer. So 2 is coming as the answer. So that is okay. But if it comes to floating point numbers, then how to do that? So there is a function called fmode for that purpose. So I will make it as previous 5.3, and there is some function I told fmode. Okay, you need to pass these two values into that function and it will work. And yeah, you need to include some header file also, that is math.h. Okay, so we will compile this. It is telling you D. Yeah, and this time this fmode returns floating point number. So in that situation we need to have this f here. Okay, so let's compile this. Oh, it is telling some fmode undefined. Yeah, we need to give the library explicitly. So -lm. See, now it is compiled, and if you want to run this, your expected output would come. See, 0.3 is coming. Okay, so this is how we do floating point modulo operations. This function, we use this function. Okay, so we are done here. Let's look at the next video. Hello friends, this question is not compilable, but still I will give you the correct answer here. So first you try to understand what I am asking. The question is, what is the declaration in below code? So is this a declaration, or this one is declaration, this one is declaration, or this one is declaration? Just try to find these numbers like 1, 2 and 3, these three are declarations. Okay, so this is your answer for that. I'll count till 5, pause the video and try to understand this one. 1, 2, 3, 4, 5. I think you would have come up with the answer by now. So see, this first one is a declaration part. Whenever we write extern in front of any statement like this, here it could be float or anything, okay, it means we are saying this is external to this file or this place. You won't get it here, okay. And this is also a declaration. This is function declaration, okay. And this is also a declaration. Actually, you don't need extern keyword to declare a function. But this is not a declaration because you are having these two curly braces. It means you have given the definition for this, even if you are writing this extern here, okay. So answer is 1, 2 and 3, which is this last one, okay. So let's move to the next video. Hello friends, this is your next question. I'll count till 5, try to understand the question. 1, 2, 3, 4, 5. I think you would have got your answer by now. So let's compile and check the answer for this one. GCC 7.c. Okay, so there is a compile time error. So the answer is B1 here. Okay, so we'll try to understand why this compile time error is there. If you are writing that this I is extern, then you cannot initialize it. Okay, so the error is this only. I has both extern and the initializer. You cannot have this and this both. Either you can initialize it or you can tell it is extern. By means of writing this extern here, you are saying that I'm just trying to declare I. And by this 10 initialization means you are telling that I will be defining this I. So at one time you are telling I'll be declaring only, and one time you are telling I'll be defining also. So that is the confusion. So if you will remove this extern from this place and will compile this again, it will compile successfully and it will run and it will give you the correct output. But the original answer for this is compile time error. Okay, so let's keep this extern here and let's look at the next question. Hey guys, this is your next question. So I'll count till 5, try to understand this question. 1, 2, 3, 4, 5. Pause the video. I think you would have got your answer by now. So let's look at the solution for this one. So this is number 8. So at least compile time error is not there. We will run this and the answer is B97. So lots of people would have got this correct answer, which is this D. So if you got the answer, move to the next video. If you don't understand what is happening here, stick to this. So you are having this character, you assign a character to A here, okay. Now you are incrementing that with this increment operator, okay. So if you don't know the way this post increment work, you might have missed the answer here, okay. So here A means in ASCII it is 97, so you are assigning 97 into this X, okay. And when you are coming out from this statement, I mean when you are coming at this line or this line, then you are incrementing this A, okay. So in that situation you are incrementing whatever is there inside A. So inside A this is there, so you are incrementing from here to next, okay. It means you are incrementing from 97 to 98, okay. So in that situation you ended up printing B here, okay. And here it is 97 only because this is post, okay. This is post, that's why this addition will happen after initialization, okay. So if I will make it pre like this one, then it will give you some another output and we will see that what is the output. See, it is 98. It means it is incrementing it before and then it is initializing it, okay. So that's why you are getting this X as 98 now. Before it was 97, okay. It is pretty much clear here. And if you are confused with this one, it is nothing but the matter of this character pointer here. If I will print it 90, if I will give 97 here, it will print A only. Let's suppose it is like that. See, 97 is the ASCII value of A, and if you will print character and pass this 97, it is going to print A only, okay. If you want B, you just make it 98, okay. C, B. And to clear your more doubt, I will give 98 here also. Okay, so it will be like 98 will come here because you are going to print the decimal value, and here you are going to convert this whatever the value is coming from here into the character. So character value of 98 is B only. Okay, that's why you're getting B here. If you don't know what I'm talking about, all these things, just go and check the ASCII chart of your C. You'll get what I'm telling. Okay, so let's look at the next video now. Hello friends, this is your next question. I'll count till 5, try to understand this. 1, 2, 3, 4, 5. And I think you would have got your answer by now. So let's check this. This is 9. At least compilation error is not there. Now you will run this and the answer is 1, 0. So this is the answer here. Okay. So if you know the answer, please move ahead and check the next video. If you don't know, stick to this. So what you are doing is you are initializing the data type, which is EMP. Okay. So you have this EMP and its data type is consisting of these 3 data type: age, cell, and integer. I mean integer, float, and integer pointer here. Okay, so if you will give it like this, the first element will get assigned here. Okay, so this age is getting this 1 and rest of the members are not getting anything. Okay, that's why if you will print this salary, this is 0. Okay, and I'm not printing the third one because it might create a dangling pointer problem. Okay, that is not good idea to print null pointer here. Okay, so in order to understand it well, you can just assume these 3. So this time it will be 1 and 3. See, 1 and 3. Okay, so it's very simple code. So I think everyone will understand this. So let's move to the next question now. Hello friends, look at this code. It is a little bit weird code because I have given this here before even this td.h. Is it perfect code? Is it going to compile? You have to think about that. So 1, 2, 3, 4, 5. And I think you would have come up with your answer. Check out the answer now. This is 10, right? So 1, 0, 10. At least compilation error is not there. And oh my god, there is no error in this code. And yes, there is no error because the compiler works on tokenization and it gets token here and there or here. It doesn't matter. You are going to use this Rupesh, and before that you have given the definition for that. So it is pretty much okay. So even if you write it here or here, doesn't really matter. Okay, we'll compile this one and get the same output here. Okay, so if you get something like that in some MCQ question, just hit yes, it is possible. So now let's look at the next question. Hello friends, this is your next question. Try to understand. I'll count till 5. 1, 2, 3, 4, 5. And you just pause the video. Yeah. And I think you would have come up with the answer by now. So let's look at the solution for this one. So this is your 11. So this is just a simple warning here. And if you run, oh my god, this is perfect code. Okay. So this my function called is the output here. Got it? But this is not a valid situation for C++. It is C, that's why it is working. If it is C++, it is going to give you an error. This is a warning. It is telling you that it is implicit declaration, but that is okay. You can get away with this. Okay, and you can just run and check that it is perfectly fine. But if I will compile this code with C++ compiler, it is going to give me the error. It is going to tell you that, okay, the first error is you need to return an integer, and the second error is my function was not declared in this scope. Okay, so I will remove this first error with this integer here because C++ always look for that. So if I will compile this with this C++ compiler, you are going to get error. This code is not compiling at all, and it is telling you that I am going to call this my function here, and till now I have not get the definition for this. Okay, even a declaration for this. Okay, so Control X, paste it here. Now this code is fine. If you will compile with C++, it will compile with no problem and run with no problem at all. Okay, so maybe you don't know what is C++ or you know, so I just wanted to tell this point here. Okay, so we're done. It is possible in your C to call some function even if it is not declared before this. Okay, So let's look at the next question now. Hello friends, so this is your new question. Try to understand this question. I'll count till 5 and pause the video and try to understand this question. 1, 2, 3, 4, 5. So I think you would have come up with the answer by now. Let's look at the answer. Answer is 1. Okay, so compilation error is not there. It is 1. And why it is 1, I will explain. If you know answer, check out next video. And if you don't know, stick to this. So this small is less than big. So first of all, I will just remove the confusion from here. This is 1 and this is 2 and this is 3. So if something like this is there, I'll just compile and show whether it is working or not. Yeah, it is working. So this 1, 2, 3 is there. Now how compiler is compiling this whole thing? Compiler is doing like this. 1 is less than 2. Yes, it is true. It will return true, and true is nothing but 1 here. Okay, is this true? 1 is less than 3. Yes, it is true. Compiler will again return 1 here, and that 1 is getting initialized here, and you are printing, you are getting that yes. Okay, so this 1 less than 2 less than 3. Okay, let's suppose it is like this. So what is the answer? Can you guess it? I know you can guess it. If you got correct output by the end, you can comment out. Okay, so 1 less than 2. This will always return 1 here. 1 is greater than 3. No, it is not. Then 0 will get returned. So whenever you compare something, there is some conditional or some comparison operator is there, or something like this is there, like if 1 is equal to 1. Okay, or I will write like 0 is equal to 0. Yes, it is true. So once this condition is checked, compiler returns either 1 or 0. Okay, so in this situation 1 will come here. Okay, and 1 is means true. You can go inside this if condition here. Okay, if it is 0, you are not allowed. Okay, so if it is like this, 0 is equal to 1, no, it is false. In case of false, 0 will get returned here. Okay, and if it is 0, you cannot come inside. Okay, the same is applicable to loops also. Like if you have while loop here, and if you have 1 is equal to 1, then in that case it is always 1, means it is always true. So this will get compiled and 1 will come here. Okay, and 1 means true. I already told 1 means true here. So I'll just simply write also true is equal to 1 and false is equal to 0. Okay, so if it is true, 1 will come here. If it is false, like if it is this 1 is equal to 0, no, it is not. So in that situation, false will come here, and false means 0. Okay, so we will check that what I was writing here before, it was 1 less than 2 greater than 3. Okay, so once we'll compile this, we'll get this 0. Okay, why? Because 1 less than 2, yes, it is true. In true case, it will return 1 here. 1 is greater than 3, no, it is not. So in that situation, 0 will come here, and 0 is getting assigned to this k, and we are just printing that k here. Okay, I think it is clear. If you have any doubt, please comment out. I'll be very happy to answer that. Hello friends, welcome back to another question. I'm just going to count till 5, and you're supposed to pause the video and try to understand this. 1, 2, 3, 4, 5. I think you would have come up with the answers or the questions, but still, let's go and compile this. So this is GCC 13. Okay, compile. So at least compile time error is not there. Okay, there would have been a warning if you are not keeping this. Okay, so I will just show you that if we are compiling, there is just a warning here. Okay, it is telling that there is an implicit declaration of this function here. Okay, and whenever there is an implicit declaration, it means your compiler is calling this one but still doesn't know where is this. Okay, because there is no declaration for that. I mean, what parameters it takes and what parameter it returns and all that. So it assumes, and it assumes means it will assume only one thing, that it will return an integer and will assign into that. Okay, so this is a basic assumption that it will do. So
So let's go and compile this. This is GCC 13.c. At least compile time error is not there now. And now this 502 and 4. 502 and 4. This is the answer. And if you know already the answer, you can move to the next question. Otherwise, stick to this video. So what is happening here? We are creating an integer a. We are assigning that integer a with this value. 502 is coming here. Everything is pretty fine. It is printing 502 with this new line character here. Okay. So if you have attended my previous videos, then I showed you that printf always return how many characters it printed successfully. Like if you are giving 1 2 3 4, which is 4 character, then if you will print what is this one, what is the output of this one, you will get how much you will get. You just guess that. I'm going to tell you that. Okay. So we'll compile this and run this. 1 2 3 4, and this is giving 5 as output. It is creating lots of confusion, right? So I will just remove all these. Compile, check. It is giving 1 2 3 4. That is okay. 1 2 3 4 is coming, but this printf is returning how many characters it printed. So it printed 1 2 3 4 and this new line character. Okay. So in that case, it became 5. 1 2 3 4, and this one including 5. So it is returning 5 to this one, and it is printing 5. So first it is printing 1 2 3 4. After that it is printing 5. See here, 1 2 3 4, and this new line is coming. So new line is doing its job, but still printf always return how many characters it printed successfully. So it printed 1 2 3 4 and this character also. Okay. So in that case, it is giving you 5. So similar thing is happening here also. You are coming, 502 is coming here, 502 is getting printed here, and one new line character is also printing, which is resulting into 4 getting returned from here, and you are printing that 4 here. Okay. So that's why it is 502 and 4. This is the answer. So let's move to the next question. And if you have any doubt, please comment. Hello friends. This is another question, and this is just a for loop. Okay. I can give you a hint. This is not a compile time error. Okay. So I'll count till 5. Pause the video and try to understand this. 1 2 3 4 5. I think you would have come up with the answers or the questions. Let's go and compile this. We compiled it successfully. I told you there is no compilation error. Okay. Now we will run this. Enter. And what is this? If I is equal to 5, so I will give 5 as input. Enter. So the answer is 5 4 3 2 1. So this is the answer. And if you know how it is functioning, move to the next video. Otherwise, stick to this video. I give 5 here. Now 5 was written something like this. And as it is non-zero value, we will go inside loop. And there is no body because I have given this semicolon here. It means this is a single statement. It will execute itself again. Okay. So this time it will go here. I told you once loop is done, it comes to third position. So this time it will come here and it will try to print whatever the value of I is, and I will get simultaneously decremented. Now this time as I was written here, now this time as I was decremented, I will get 4 here. 4 is also a true value. You will again go and print 4 and I will get decremented by 1. So this time 3 will come. Again 3 is a non-zero value. It will go get printed and it will become 2 now. So like that it will print up to 1. One time this will get 1. It will go here. It will get decremented by 1, which means I will become 0. But before getting 0, as it is post increment, it will print that. So 1 will get printed here and then 0 will come here. Okay, because I has changed it. So 0 will come here. Now you are going to terminate that. That's why this loop is going from 5 to 1, not 5 to 0. Okay, so let's look at the next question now. And yeah, please, if you have any doubt, comment out. Hi guys, this is another question. This is just one line question, but still lots of people don't know whether it will compile or not. So I'll count till 5. Try to think about it. 1 2 3 4 5. So GCC 22. It is compiling successfully and the answer is
this one. Hi, this is Rupesh. Okay, so from here to here. If I will give something little bit cleaner code, then it will be very easier to see this. Yes, hi, this is Rupesh. So what you understood from this, there is no difference between writing it like this or writing it something like this. You just remove this all. There is no difference in between these two. Okay, today you learn lots of things, right? So if you want to learn more, go to the next video. Hello friends, so this is a very silly question, I know this. Okay, so just try to find the answer for this and we'll quickly move to the next video. Okay, 1 2 3 4 5. I think you will come up with the answer, and I know the answer is 100. Okay, so let's compile this code and run this. Answer is 100. Why? Because there is a structure, its name is book. You created the object of that structure, and this b.pages you are assigning 100, and you are just printing that 100. Okay, so there is no fancy thing or no error or no need to dig into this much, because it is really very simple question. So let's move to the next question.
Hello friends, this is Rupesh and watching CP Nuts video series on C interview questions, and in this question we'll be learning about how to find the loop inside the single linked list. Okay, so how to find the loop in the linked list. So there are basically 3 ways of doing this. There are other ways too, but I find these 3 more interesting. So let's discuss one by one. So the first is mark each node. So as you can see, you have these nodes, and this 1 2 3 is the data part of your node. Let me write the struct for this one. So this is your structure, this is your data part, integer, and this is for next. Okay, so if you will create a node of this type, it will look something like this. So first one is mark each node. Marking requires one more extra field to be included in your original structure. It could be a boolean flag, like you can include another thing here saying that bool visited, and when you are creating this list, that time you initialize this visited with false. So let's assume you have initialized false, false. Now what you are supposed to do for first case, you will start from here, as this is your starting node, and once you reach, you will check whether it is false or true. If it is false, you will make it true and you will go further. This is again false, you will make it true and go further. Similarly, you will make it true and move here. Make it true, true, and similarly true. When you will reach here, you will find that this is already true. So if you found that visited variable true, then you can say that, or you can return from that function, whatever that function you have created for this detection, true. Okay, that you have found it. So this was the first way of doing this. The drawback of this one is you have to have this extra field. If it is C++, you can have this as a boolean, and if it is only C, you can go for character. Okay, character visited, and you can initialize 0 and 1 in that. So this mark each node way require extra space in each and every node. So you will be losing 1, 1, 1, 1, 1 and 1, total 6 byte in order to find the loop in your linked list. So this is not the best way to find the loop in the linked list. So let's move for the next one. So the next one says that keep a hash set of all the nodes seen so far. So how you will keep the hash set? So if you have a linked list, you must be having some address, right? So let's assume that your address is 0 cross 0, 0 cross 1, 0 cross 2, 0 cross 5. So this is the address of your one node. You always create linked lists using dynamic memory allocations, and we get these addresses when you create a node. So these are the real addresses. Now what you will do, as it is telling, create a hash set of all the nodes seen so far. It means you will be having one data structure, maybe let's call it a set. So the working of this one is like you will start from here, and keep on pushing this address because your all nodes will have different address. If you'll store the values at these nodes, some node can have multiple similar values. Okay, so this is 1 and here you can have 1, but these address will always be unique addresses. So we'll store the address. Before storing the address, we will find whether this address already exists in this set or not. So if it doesn't exist, we will store that address and we'll go further. Store this one because this doesn't exist. So first you will find inside this set, and if it doesn't exist, you will store that and move further. So this one, then 0 cross 2, again 0 cross 3, 0 cross 4, 0 cross 5. Okay, you will reach here. Now this one is pointing to this one. So as soon as you go here, the address of this one will be 0 cross 2, and before inserting into this one you will find that 0 cross 2 already exists and you will return true. Okay, it means you have found a loop. And let's suppose if this linking is not there, means this is not linking to this one, it is null, then you will have a null value here after this 5 and you will terminate that loop, whatever the loop you are using for finding this one. Okay, so at last, as you have not found any address existing inside this one, you will return false from that. Okay, so that was about second one. Now let's look at the third one. This is very interesting and very famous in the interview questions, and they expect this from you. So let's understand this one. And catch loops in two phase is also called Floyd's cycle finding algorithm or the tortoise and the hare algorithm. Why tortoise and the hare? We'll see that. So this is how it will look like, and for this you need 2 pointers. Let's call it a slow and a fast. And the idea is you will increment slow by 1 and fast by 2. So by doing this, you will ultimately reach to a place where both small and fast pointing to the same node. Okay, and we'll see that practical here. So as I said, small, and yeah, if there is a loop, then only they will point to the same location. Otherwise this fast will reach to the end and your loop will terminate. Okay, so as I said, small will go 1 by 1 and fast will go by skipping 1. So this fast will go here. So let's make this fast, this is slow. Then again this is slow and this is fast, and fast is not equal to slow. We'll move further. So fast will go here, fast, and slow will come here. They are again not equal. So you will move fast here again. You will have fast again, and small will go here. Okay, now again fast will go here, here, and slow will go here. And as you can see, fast and slow both are at same location. So we have found the loop here, and this is the best algorithm to find the loop in the linked list. Always remember this, slow and fast. And now you can understand why it is called tortoise and the hare algorithm. Tortoise is this small guy and hare is this fastest guy. And if you don't know what is hare means, it is similar to the rabbit. Okay, so rabbit jumps and go fast, and your turtle go little slow, and at one point of time they will reach to the same location, and there you go, you found the loop in that. And this is how you find the loop in the linked list. So we have discussed all 3 ways. I'm not going to show you the code for this. You can easily get it if you'll Google it. So thanks for watching. I hope you liked the video. If you did like it, don't forget to hit the like button. Bye bye.
Hello friends, this is Rupesh watching C++ video series on C interview questions, and this question is about string literals, and interviewers confuse people so much by asking the string related questions. So I will try my best to sort out few of them. So bear with me. We'll enjoy this video. So string literals are constant strings and can't be changed. So
Generally, this is how a string literal looks like. There are other types also, but I'll be discussing this one only because you can put L here for string literal, then you have to change this type, but no one asks that much advanced string literal. They just try to confuse you with the basic ones. Okay, so the actual meaning of string literal is your string is constant. Okay, you cannot change that. I mean, this value can't be changed using this str1 because this is inside read only memory. Okay, so I'm trying to tell you is like, if you are willing to change this str1 location, whatever, maybe second location is equal to, let's make it a. So second location means this p here right now. So what you're saying, you want to change this p here with a, but this is not possible. It will compile, so let's check that. So if we will compile this code, see, it got compiled, but as you will go for running this, it will give you a bus error, and maybe in your computer you will get segmentation fault. The difference between bus error and segmentation fault is that segmentation fault means the memory you are trying to access is a valid memory, but you don't have the rights to access that memory. But in this kind of bus error means that memory what you're trying to access is not valid. Okay, maybe you're asking some memory which doesn't exist at all, so that's why you got this bus error. So as I said, you won't be able to change this because this is a constant string, okay, and can't be changed. So always remember, if you are having character pointer string, then you cannot change that because this will go to the read only memory of your program. You cannot change this. This is not rewritable. So this was the first point. Now let's look at the second point. The second point is pointer can be changed to point to some another string. Yes, you can do something like this. You have some string pointer str2, you can make str1 here. Or to say that you have some str is equal to, let's make it Rupesh Yadav, and later you're trying to change this str2 is equal to str1. So this is quite possible. Let's check that. Printf %s, and if you'll print str1, and let's make this printf2 str2. So save this, compile this. It got compiled. If you'll execute this, cpp nuts, cpp nuts. So you're getting 2 times cpp nuts, means you're getting this one 2 times. So I mean, you can make this pointer to point something else, but the point is you cannot change the ultimate data here. Okay, this string may point this one and this string may point this one, but either of this cannot be used to change their data. Okay, so that's the important point here with the string literals. So that was the second point. Third point is, as string literals are constant by nature, applying constant keyword gives extra benefit. So now here is the main important point. There was a time when I was also confused when I was asked this question, like let's make this simple clear. Yeah, so as I said, this is a constant and you cannot change that. But someone said, what if I apply constant here? Then what will happen? And mind that applying constant here and applying constant here, like const, is totally different thing. Here you are saying that str cannot point to something else. Okay, so this is totally different than this. So here you are saying that this character pointer is a constant character pointer, and it means you cannot change the data, and without applying this also you cannot change the data. Then what is the meaning of applying this one here? So this was a pretty good question and I was not able to answer this question. Then I googled it and I came to know that there is a good reason behind using this constant, and that good reason is, did you remember that you was doing something like this, str0 not 02 is equal to something like this, and it did compile, correct? Let's compile this again. See, here you are getting the error. So the read-only variable is not assignable. Means now your code won't compile. Before, without applying this, let's delete this, your code will compile. Let's compile this again. See, it got compiled. But if you will use constant here, your code will not compile. So accidental changes to this string can be avoided using this constant. Okay. So this was about third point, I guess. Yeah. So the fourth point is creating array of string is not string literals. Yes. So let me just remove this and create something like arr cpp nuts. So this is the array of the characters, and this won't be stored at read-only memory. This will be stored at stack, and you can change this because this is not a constant. If you make this as constant, then you cannot change that, but without constant you can change it. Okay, so as I told that you cannot change this one because this is a string literal, but this can be changed. So if you are planning to change something in future, then you should make it as string array, not the string literals. So something like this, q, and we'll save this, print this arr, and we will get cpp and qts. So let's check that. Compile, execute. See, cpp and q is there, u is gone. So this is working. So as I said, using array, it is possible to change this because this is not going to store at read-only section, hence can be changed. So this was maybe the fourth point. Fifth point is we can change non-constant array in strings. Yeah, that's what I showed you here. So the sixth point is experiment with the function passing. Okay, now this is the time to experiment this with the function passings. So let me create a function here, void function. Let's make this character ptr, and try to change this ptr with something like 2 is equal to a. Okay, and that's it. And what you're trying to do is you're not keeping this as a constant here, and you have this array, and let's copy and paste this here, remove and make it ptr, and comment this one and pass fun first with this str1. So as you know that this is a constant string, I mean a string literal, you cannot change this. So you're passing this address here and you're trying to change it here, which is undefined behavior. Okay, and yeah, I forgot to tell you that if you are attempting to change this, this is undefined behavior. So that's what we are doing here. So let's compile this. At compile time, it will not give you any error because you're not having this as a constant. So we'll check that as well. So first, let me compile this. GCC, it got compiled successfully. And if we will run this, it is giving you bus error as expected because you're trying to change this, which is a constant. Now, if you're sending ARR, which is allowed to be changed, this will work. So let's check that. Compile, execute, CPA. So that second place is changed. Correct? It should be CPP, but it is CPA. So this was the small experiment with the functions. And yeah, I was telling you that if this is constant, then you cannot change this. So let's compile this. This is the problem with C code actually, because it will automatically remove this constantness because we are passing this one here. So this is the problem with this C code. So if we will compile this with G++, you will get the error. See, you got the error, no matching function for call, because you are passing a constant to a non-constant. So this is not allowed in C++. And this is the problem with C compilers. It will automatically truncate this constant away from this ARR and will pass that pointer here. So don't get confused. C is little bit liberal in all these things. C will implicitly cast away this constantness, but C++ doesn't allow that. That's why you got this. So clear the screen. And yeah, So if we will remove this constant here and pass this str1 now. So the same case will go with this. If we have constant here, and let's compile this. So in G++ it won't allow because this is C++ compiler, and if this is GCC it will allow. But again the behavior is undefined. So as you are passing this constant from here to here and you have successfully compiled and you will try to run this, then you will get this bus error. Okay, so that's it. This was about string literals. Now wait a minute, there is this raw string in C++ 11. So now this won't be a C question, this will become a C++ question for this 7th statement. Okay, so I have copy and pasted that full code here in callyourstackdcrook.com. This is online compiler for C++ and I like this. As I said, this is C++ feature. We don't need all these C++ header includes. We need iostream and using namespace std, and it won't work with character pointers, so you have to use a string here and no need to use this printf. So we can use cout str1 and that's it. So if you'll compile this, it should compile good. See, it is giving cpp/n. So this is the use of your row character. It is saying that don't interpret anything with some special behavior. Everything is just simple characters. So this /n doesn't have any special meaning inside this. Okay, and that's just because of this capital R and this syntax, this opening and closing round bracket syntax. Correct? So let me just show you this. If you will remove this capital R from this place and try to compile this, see, it is printing this CPP and then nuts in the next line. Okay, so this has a special meaning right now. So if you will apply this capital R, which makes this string a raw string, in that case it doesn't have any special meaning inside this, and it is printing whatever it is getting in between these opening and closing round brackets. Okay, so that's it. I think we are done here. Thanks for watching, and if you like the video, don't forget to hit the like button, dude, and make sure you subscribe to my channel so that you will get the notification for my upcoming videos like this. I'll see you in the next video. Bye bye.
Hello friends, this is Rupesh and you're watching CPP Nuts video series on C programming, and this topic is sizeof is a function or an operator. So this is a question. So let me tell you the answer for that. It is an operator, not a function. Okay, even though it looks like a function. So let me show you that. We can have this integer x is equal to 0 and have this printf and this d size of x plus plus. So what it is going to print? It is going to print the size of this x, and if you want to print this x after this, so let's do that. Just printing x. How it looks like? So it's like it will calculate the size of this x plus plus result, and x will be incremented by 1. So it is 0 and then it will become 1, but that's not the case. And this should be d here. And so let's check that. So you got this 4, and yeah, we got some warnings here. Okay, it is telling that we should have this ld. Compile it again. One warning is gone, and this is another warning. It is telling you the same thing what I'm supposed to tell you now. It is telling that it has no effect in an unevaluated context. So what it means, it is saying that I'm not calculating this particular expression here. Because this sizeof is not a function, it is an operator, and it will be evaluated at compile time. So actually this full thing is replaced by 4 at compile time. Okay, so when you are compiling this program, your compiler will replace this full thing with 4 like this. Okay, so that x plus plus is already gone. That's why you are not getting this x incremented when you are compiling this code. So this is the reason you are getting this 4 and 0. This x is not incremented. because this is evaluated at compile time, not runtime. And third point is what I explained here. It does not calculate the expression because it will end up replacing that with some number. If it is integer x, it will replace with 4 here. And just to verify that, let's call some function and pass some value. Let's pass 4 here and have this double function, and this is just integer x, and this function is not doing anything fancy. It is just going to print this x for you. Okay, so there is no problem. You can do this. Okay, so compile this and forget about this warning. It is just telling you the same thing what I'm explaining here. See, you got this sizeof function as 8 because it is checking what is the return type of this particular function. If it is double, then double size is 8. That's why you ended up getting 8 here. And if we'll change the size here, let's make it integer. And if we'll compile this again, see, it has become 4 now. Okay, this is how it will work. And one more important thing is, this is not going to call this function. See, we are not calling this function. It is not printing this x or 5 here. Okay, because again, it will be replaced with 4 here in case of integer. Okay, and the last thing is parentheses are optional. Yes, it looked like a function just because of these parentheses. Okay, but it is not required at all. So if I'll compile this, see, it has still compiled and giving you the same result. So I know you didn't know that sizeof operator is an operator or a function, and it can take argument without parentheses. So if you learned something new today, don't forget to hit the like button, and let's summarize this video. I'll see you in the next videos. Bye bye. And yeah, don't forget to subscribe my channel to get the update for videos like this. Bye bye.